Welcome back, ladies and gentlemen. History of motion, Aristotle. All right, so up until now, we've been talking about these terms, right? We've talked about acceleration, we've talked about velocity, we talked about displacement, we talked about time, and we talked about all of their scalar versions, and all of this is basically the nuts and bolts, the pieces of physics. But we haven't really figured out the overall plan yet, how they work. We also did graphs, of course. I'm sure you're all very, very happy about the graphs that we did, but those are all just tools. Now we're going to talk about how all of this sort of unfolded. And it's got a bit of a history lesson here. So we've got Aristotle, starting with him on page 54. So he was born a long, long time ago, not quite in a galaxy far, far away. It was 384 BC. So right now we're in 2020. So 2020, we'd go backwards to 0, and then we would go 384 years before that. So he's at least 2,400 years ago now. So he was a famous philosopher. In point of fact, if you continue to do science, you are going to find his name comes up everywhere. Now, ancient Greece was a pretty prosperous place. It was doing really well. They had global trade. They had all the latest technologies. It was a great place to live. And as a result, they had the wherewithal, the time to have an educated class of elites who could just spend their time thinking instead of having to work with their hands all the time. Of course, we now have that as sort of more of a general trend. You guys are attending school. In the old days, back then, you wouldn't get to attend school. You guys would be stuck working instantly, probably from about the age of 4 or so. You could probably help carry firewood, for example. So, Aristotle was a well-to-do guy. He was able to spend a lot of time observing things, and he was great at observing things. He wrote down tons of his observations. He recorded that information and made sure that it was available, and he made inferences from that observations. Basically, he studied things and he figured out, what does that mean? What does that mean beyond just what I see? So, as you can see here in the notes, it says that he was so dominant in the European sphere of learning that he was merely known as the philosopher. The term philosopher was used to mean any smart person, basically. A PhD. PhD is the abbreviation of the Latin phrase, I can't remember it now, but I know it translates to doctorate of philosophy. The D part is the doctorate, and then the PH part is philosophy. So a PhD is somebody who has a doctorate of philosophy, aka you're a smart person like Aristotle. And when you were a philosopher in the early, not philosopher, scientist. The word scientist used to be called a natural philosopher as opposed to a non-natural philosopher. A non-natural philosopher, just a philosopher, was someone who focused on the ideas of thinking itself and the heavens and how do people learn and what do people think and what does thinking even mean? Very complicated stuff. Most people don't like to worry about that. But a natural philosopher was like, what happens if I punch something? How does it behave? Right? They studied the natural world, hence their name. Eventually they got the name scientist instead. So Aristotle believed in qualitative data collected through observation. He believed that you could observe things by doing an experiment. That said, he didn't really test his observations or try to repeat any of his experiments. He just was like, I have an idea, and because I'm so smart, it must be right. He really struggled when it came to numbers. He wasn't a numbers guy. He was a bio guy. And here's kind of the thing. Aristotle comes up a lot in biology. He was sort of the founder of biology in a lot of cases because he went out of his way and said, animals are cool and all, and so are plants, but I bet you we could group them into categories. We could study those categories. We could understand things about them. And he's sort of started this whole thing. And when it comes to biology, he did great. He did top-notch work. We still use some of it today. Everywhere else, he kind of dropped the ball because it turns out that when you don't like numbers, it becomes hard to measure things. Right? Physics, as we've seen, has got a lot of numbers in it. Chemistry had a lot of numbers in it. So yeah, he struggles with numbers. He proposed that every object has a natural motion towards the center of the universe. Put another way, he sort of said this. He said, okay, for our purposes, we're talking about physics, we're talking about motion. He said that this object here, it's a marker, it has a natural place that it's supposed to belong, right? It's supposed to belong in here. So if I lift it up and I let go, it goes back to its natural location because that's where it's supposed to be. His examples of this were that if you took a rock from the valley floor, you took it up to the mountaintops, Greece is very mountainous, and you let go of it, it would roll back down into the valley because the valley is where the rock came from. That is its natural place to be. Similar, if you took a rock out of the ocean and you let go of it, it would roll back into the ocean. You take water out of the ocean and you pour it on land, it flows back into the ocean. So everything was all about where it's supposed to be based on just, that's natural. And it was his basic idea. Well, the problem, of course, is that as we can see here, right, all right, it goes back where it was. Oh, only if it's directly above where it started. Oops. Aristotle didn't do a lot of experimenting. He just came up with ideas that sounded good and then sort of ran with it. And since everyone was like, Aristotle's pretty smart, it must be true. So, unfortunately, the main thing that Aristotle comes up with these days, especially in physics and chemistry, is for us to say that he's wrong. Yay. All right, moving on. Page 55, Galileo Galilei. He was sort of considered the father of modern science because he sat down and went, that Aristotle chap was okay, but what happens if we measured things? So he did what we called quantitative measurements. So qualitative measurements are where you just sort of see things and you think what they could mean in sort of an abstract way. Right? That cat has 4 legs. That's I see that cat has legs. A quantitative is where you're like, I'm going to measure exactly how big those legs are, down to the centimeter. And Galileo was a big guy on experiments. He liked to run experiments to prove that his ideas were correct. Now, as a result of that, he tried to test a lot of Aristotle's stuff because everyone at the time was like, Aristotle's a genius, and Galileo was like, has anyone ever looked into this stuff? Right? Have you checked the references? And when he did that, he discovered that actually, no, most of his stuff was wrong. So obviously this did not make Galileo a lot of friends because everyone else was like, Aristotle's amazing and you're saying he's wrong? Well, obviously you're just an idiot and I don't like you anymore. Not helped by this fact was the fact that Galileo was a bit of a jerk, right? So Galileo, case in point, an example here. Famously, Galileo did a lot of astronomy, right? He invented a telescope, used it to look at the stars and the planets, and he discovered that the stars and the planets were not completely unchanging dots of light like everyone originally thought, because he could see them a lot clearer, and he realized that the planets had shape and color and moved. And he discovered moons around Jupiter, called the Galilean moons, named after him still. And he wrote down all of his amazing astronomy works in a book, which is normal. Everyone does that in the old days. I found this cool stuff, I'm going to write it down. But he wanted to make his book more interesting rather than just being a textbook of, 20 boring things I discovered about space. So he made his book into what's called a dialogue, sort of this back and forth story between different people. And so what he did was he would have a character who was sort of called, Galileo's from Italy. So everything was in Italian. So his character, he had the one character which was sort of like the John Smith of Italy, right? He was the common man. And he would always pose questions about the world around him, wondering about things, because Galileo assumed that the average person was very curious about the world around them, much as any teacher assumes about the students. So the common man would always be like, I wonder how this works. And then Galileo would have a different guy come in and explain how this works. And that guy would always be wrong every single time, because he would always do some weird Aristotle thing that wasn't right. Then Galileo would have another person that was basically him, but with the name slightly changed, come in and tell the right thing. And then the common man would always be like, oh, Galileo, you're so smart. And oh, other guy, you're so dumb. Now, Galileo was apparently good at doing experiments, but he wasn't very good at being, we'll say, subtle. So there was a couple problems with this book. First of all, the guy who was constantly saying the wrong thing was given a name that in Italian is very close to the Italian word for stupid. So, it's almost like a comedy sketch where you've got John Smith, going up to two people and is like, hey, smart guy and Dumbo, which one do you think has the right answers about all this stuff? So already he wasn't really helping to make everything, a fair discussion. He was just saying like, yeah, okay, this guy's dumb, I'm going to call him dumb, and I'm over here and I'm smart. Oh, but it's not me. I'm going to change some of the letters around. So by itself, that wasn't going to help. It got a little worse, though, because Galileo, for whatever reason, decided to make it so that way Dumbo over there was the king of his country. Yep. So he was like, okay, so I'm going to write a book about how dumb these ideas are, and I'm going to make the king say it. There we go. That'll sell some books. Everyone will like laughing at the king. Well, the king didn't like laughing at the king too much, so the king sort of went to Galileo and said, hey, dude, not cool. What are you doing? And Galileo's like, I'm not doing that. I'm just doing science. Just science. Yeah, okay, sure. You're just doing science. Stop saying I'm dumb, okay? How about you change that, change it to somebody else or whatever, and you can keep publishing your stupid book. Galileo's like, no, I don't want it. And the king was like, okay, well, under normal circumstances, I'd probably just chop your head off at this point, but I'm a nice guy, so I'm going to say that you are not allowed out of your house until you agree to change the book so it's no longer talking about me. I mean, the rest of it's fine, you just don't talk about me. And so Galileo was stuck under house arrest, which is something that I'm sure none of us know what it's like anymore. And as a result, he was sort of stuck there until he finally decided to change his book a bit. Now, to add to this little kerfuffle, the king of Galileo's country had another job. His other job title was Pope of the Roman Catholic Church. So this turned into a conflict between the church and Galileo because he was insulting the guy who was in charge of his city, who happened to be a guy with two jobs. So it didn't go well for him. Other things that Galileo did that were kind of weird. Again, he lived in Italy. For those who haven't looked at a map, Italy is not very big in terms of width. It's really long, but pretty much all of Italy is within sight of the coast, just about. And Galileo, living near the coast, obviously did a lot of experiments on water. And he worked out in great detail with mathematics and some things based on his telescope readings, and he figured out that there should only be one tide a day. Now, we live in the prairies here, but maybe some of you guys came from coastal areas. The tide, what happens is the oceans actually rise and fall during the day based on what's effectively the pull of the moon. When the moon is overhead, it pulls the water up, and when the moon moves away, the water sinks down again. And this results in the entirety of the Earth's oceans kind of almost breathing. And the tide is very important for ships, because if you try to take this really big ship and you try to go into a place at low tide where the water's down, you're going to run aground. You're going to hit the ground. Whereas if you try to go in at high tide, you got lots of room. So the tides were very important to the Italian people who lived on the coast, everything was coast. And then Galileo shows up and is like, okay, so there's only one tide a day based on my math. And everyone was like, dude, we can see the water. It's right there. And the tide comes in twice. It's right there. To which Galileo was like, no, you're wrong. My math shows that it's once. Okay, Galileo. So he was really good at a lot of the scientific analysis. He was maybe not the best at dealing with people, and that's sort of a trend that continues with scientists to this day. A lot of scientists really struggle when it comes to sort of interacting with people on a regular basis. Now, what this also means, and the reason why I like to bring up these stories about, Aristotle and Galileo and all these things they do, is because very often students tend to think that, all these scientists were very smart and they've got all these answers written down in their books and everything, and that's it. There's nothing else to discover. Scientists are people. They're people just like you. They're people who, like to go and watch sports and play video games and go to the movies and any number of these other things. They're just people who also like to ask questions of, why does that work that way? What does that mean? And then to try and figure them out. So they have their unusual behaviors, their eccentricities, but it was still pretty good. And there were other things that Galileo did. I've told a couple stories of things that are wrong, obviously, because they're funny. He did some really good things, too. He was able to figure out the idea that two objects will hit the ground at the same time, or in this case, fly all over the place, no matter their weight. This is a weird idea for most people, right? Like if I take a set of keys and I take a pen, and the keys are much heavier than the pen, and you ask somebody, hey, which one's going to hit the ground first, the heavy thing or the light thing? Most people go, wow, heavy thing, because it's heavy. But it doesn't. If I drop the two, they hit the ground at the same time. Heck, I usually do this one in class, and I like to really mess with people because I do it with paper and then something really heavy. I get something like super heavy. And so we'll do keys again, right? So if I drop them, they both hit the ground at the same time. You'll see it in your screen. They just fall right through the screen at the same time, even though paper is, of course, super light. Now, there is a way to change how the paper will fall, in that instead of dropping it vertically like this, I drop it this way. And then it sort of flutters down. Galileo figured out that objects don't fall at different rates just because they're heavier or lighter. They fall at one rate and one rate only. Acceleration. There's only one acceleration on Earth. Now, why did the paper flutter when I turned it sideways? Because the air pushes up against the paper. The air sort of cushions its ability to fall. These keys, the air is trying to cushion them too, but the keys, they're too heavy, so the cushioning effect doesn't work as well as it does for paper. This experiment Galileo did in the most unusual way, right? You wouldn't have expected it. He did it by taking two objects and dropping them in oil. And then he dropped them in water. And then he dropped them in air. And what he found was that in oil, the heavier object would hit the ground first because it could push the oil out of the way faster. In water, the two of them were closer together. In air, they were closer still. And he reasoned that if there was no fluid, no liquid, no air, no water, no oil, then the two objects would hit the ground at exactly the same time. And that was it. That was his logic. And here's the weird thing, of course, in case you didn't notice, we have air everywhere on Earth. So we couldn't really prove that his experiment was correct. We just sort of had to take his word for it, which eventually people actually did. Well, we were able to prove it eventually. One of the links that's inside the lesson plans here is a picture, a video, when in the 1960s, NASA first sent a man to the moon, and they did Galileo's experiment in an environment with no oxygen, no atmosphere at all, the moon. They dropped a hammer and a feather on the moon, and they both hit the ground at the same time because there's no fluid to push the air up, the feather up, I should say, no air to push up the feather. There were other things he did as well. He was also the one who figured out that when you drop something, it tends to continue to fall straight down. So this is going to be another one. Let's see if I can demonstrate it. This one's always hard. It's going to be hard with the screen. The screen's not very big. So Galileo, people were debating this particular point during Galileo's time, and they said, okay, so I'm on a sailing ship. Sailing ship's going along, and I've got a guy on the top of the ship in what we call the crow's nest. So he sits up here, and you see him in like pirate movies. His job is to look around and see things. So he's up here. If he drops something, what'll happen? Right? The ship is moving along, and this guy up here, he drops a thing. Well, some schools of thought were that the ship would keep moving, and the thing would just fall, and it would fall behind the ship. But Galileo demonstrated that's not what actually happens. If you drop something on the top of the ship, it will fall and land on the deck of the ship, directly underneath the crow's nest. You could see this with, say, I don't know, if you've got a skateboard. If you've got a skateboard, right, and you're rolling down on your skateboard or your rollerblades or any other bike, any other moving object, if you drop something, it will fall with you until it hits the ground. Again, I've got some videos about that you can see. So, Galileo had some things wrong, but he also had some things right, and it was pretty cool in those ways. All right, flip over the page. Sir Isaac Newton. This guy is big for the next unit that we're dealing with. The dynamics is pretty much everything Newton did. He was born in the same year that Galileo died, and he was an English guy, so from the UK, and he developed in the laws of motion, and Newton was another one of those colorful characters. Okay, so remember, I said, scientists, Galileo was very smart, not great with people. Newton, very smart, also not great with people. Okay, so, one of the stories is that he was so clever that his parents sent him to school. I know for you, who are stuck at home now doing school, even though you're not even here, that seems weird. But in the old days, as I said, you wouldn't go to school unless you would pay for it. So his parents had to make extra money in order to send Mr. Smarty Pants to school. And why did they do that? He was pretty clever. He ended up he was doing so well, they sent him to university. Now again, I know you're going, what's the big deal? Back in those days, there was like 5 universities. There was 2 in England, 1 in France, 1 in what is modern day Czech Republic, and then there was another one in what is modern day Austria, if I remember properly. Might have been Berlin, actually. Doesn't matter. Point is, there weren't a lot of universities, so getting to go to one of them was pretty big. And then when he went to university, there was a problem. So you see, very topical here, there was a plague, and so the universities and schools closed down because they were all like, whoa, 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 I don't want to get sick. So they sent everyone home. And Newton was like, I don't want to go home. Home is boring. All that I can do there is like party and relax and go outside and spend time with my friends. And I don't want to do any of that stuff. I'm going to stay here. So he sort of stuck around in the campus grounds of the university, but he had to stay away from everybody because social distancing was a thing back then too. And he did math. Yeah, he just did homework. Except it's even better. He didn't just do any old homework. He was trying to work on understanding the motion of objects, this unit. And what he discovered was that, it was too hard. He couldn't solve it because, I kid you not, math wasn't good enough yet. So, on his break from normal classes, because the plague was meaning he couldn't go to school, he invented an entirely new branch of mathematics called calculus. So, not saying that you guys are slacking, but any of you guys invented an entirely new branch of mathematics yet? Got the same motivation. You're also stuck away from school. All right, kidding aside, his calculus was actually also invented at the same time by a French guy called Leibniz. And he was literally at the same time. The two of them were doing it independently of each other. And we actually use Leibniz's notation when we do calculus. For anyone who's doing calculus class, that's Leibniz's notation, not Newton's, because Newton's notation is a little, it's not good. But of course, usually Newton gets the credit for calculus in the English-speaking world because the English sort of do this. French made calculus too? No, I think our guy did it better. Because England and France didn't get along for a long time. So, anyway, you've got this whole back and forth thing going on, right? And he invents calculus, he invents his laws of motion, and his laws of motion are pretty critical. Now, since Newton, it's been like, about 400 years or so, give or take, we've had a chance to refine his laws of motion. So you don't need calculus to be able to understand Newton's ideas. When he first discovered them, he needed calculus because it was pretty complicated. But now we were able to go with it and go, oh, Newton, you're pretty clever. We're going to take this and work with it. I will talk to you guys next time.